Hello everyone. Welcome back to our course Fundamentals of Semiconductors. In the last class, we clearly know the differences between intrinsic and extrinsic semiconductors and drift current and diffusion current, and what is Hall effect and what are the applications of Hall effect in day-to-day life. Okay, now in this class we are going to learn about the PN junction diode. Okay, how the PN junction diode form and what are the bias of the different bias of the PN junction diode, and what is PN junction diode, and what is the characteristics of PN junction diode in different biases, and what are the applications of this PN junction diode we are going to learn in this class. Okay, now we all know that by adding a trivalent impurity to a pure semiconductor, we will get a p-type semiconductor, and by adding a pentavalent element like arsenic, phosphorus to a pure semiconductor, we will get the n-type semiconductor. In the p-type semiconductor, majority charge carriers are holes and minority charge carriers are electrons. Similarly, in n-type semiconductor, majority charge carriers are electrons and minority charge carriers are holes. Now, we all know that the difference between drift and diffusion currents, which we have clearly learned in the last class. Okay, diffusion in the sense the flow of charge carriers from the higher concentration to lower concentration without any external energy. It is a natural process. I said na, it is a natural process. Okay, to get the stability or to get the equality in the nature, always everything moves from the higher to lower. So here also in any material, the charge carriers moves from the higher concentration to lower concentration without any external energy. This process is diffusion, and the current due to the diffusion of charge carriers is diffusion current. Then drift current means by giving the external energy, if we are moving the charge carriers from one place to another place or from one direction to the another direction, then we will call it as a drift current. Okay, now just keep these things in your mind to understand the formation of PN junction diode in a clear manner. Now let us go for the PN junction. PN junction, that means adding of or joining of p-type and n-type material together is known as PN junction. Okay, this is different types. We will take a p-type material and n-type material, then we will add together, or else we will take a pure intrinsic semiconductor and one side we will dope with a pentavalent element, that is this region will be act as n-type semiconductor, and another side we will dope with trivalent, then this region will be act as a p-type region. Then when we join together, there are different process to join this p-type and n-type material. Those are, we can see that special name is growing, alloying, diffusing. These are the different methods to join the p-type and n-type material. Now if I join a p-type and n-type material together, what will happens and how a PN junction forming, that we will see now. In this image, we can clearly see that we have taken a p-type material here and we have taken a n-type material here. Then when we add together, when we join together, initially, naturally, the diffusion process takes place, because in the p side, higher concentration is holes. In the n side, higher concentration is electrons. In the p side, the scarcity of electrons is there. In the n side, the scarcity of holes is there. Then automatically natural process takes place, that is diffusion. Then whatever the holes are there in the p region try to diffuse towards the n side, and whatever the electrons in the N side try to diffuse towards the P side. Okay, then what happened? Whatever the electrons, you can see in this image clearly. Now these are the holes from the P side and these are the electrons from the N side. Then when we add together, initially these holes are trying to cross the barrier towards the N and these electrons are trying to cross towards the P side material. Then what happened means recombination of electron and hole will be takes place. Recombination of electron and hole will be takes place. This electron from the N side and this hole from the P side, they will be recombined and get stability. So that whoever come first from the N side, that will be recombined with the holes, and whoever come from the P side, they will be recombined with the electrons, and they will form a special region called depletion region. This region where the recombination of electron and holes will be takes place. Recombination of electron and holes will be takes place. That region is known as depletion region. That means they got stability. Okay, when it happens, now we can see this, the further flow of holes from the P side to N side will be opposed by these positive ions, and the further flow of electrons from the N side to P side will be opposed by these negative ions. That means this region also, it is a recombination region. It is also a recombination region. So whoever holes are moving from the P side to N side, whoever come first, they recombine with the electron here. Whoever the electrons move from here, they will be recombined here, and they will form a immovable region. Immovable region means they got stability. They form a wall. Because of this recombination, they got stability and there is no vacancy, there is no excess electron. They will form a wall between the P type and N type material, so that if I want to get the flow of current through the junction, I must break this wall. Okay, this wall is known as depletion region or forbidden region. Forbidden or depletion region means where an electron is unable to move. So that even in this, where you can say here, where charge carriers are unable to move, either it is a hole or either it may be a electron. Okay, now if I want to get the flow of current over this junction, what I need to do, I should give an external energy which can able to break this wall. Okay, then only I can able to push the holes from this side to this side, and I can able to push the electrons from the N side to P side. So that required voltage to cross the barrier is known as threshold voltage. Or critical voltage or threshold voltage or transition voltage or breakdown voltage. There are different names. Okay, that breakdown voltage means the voltage required to break this depletion region. Okay, this is the formation of PN junction. Okay, then we will take a P type and N type material, add together, simply diffusion takes place and they will form a immovable region. That region is depletion region. Then what is PN junction diode? Okay, it is a two-terminal device which we can use in the different electronic circuits to control the flow of current. That means we can able to increase the current and decrease the current. We can also act like a switch of the current. As I said in the introduction of semiconductors, these semiconductors can be act like anything, like an insulator, or it may be act like a perfect conductor based on the inputs whatever we are going to do. That's why we are focusing on the semiconductors everywhere. Okay, now PN junction diode symbol we can see here. This is the P region and N region, and this arrow mark always indicates the direction of the current, flow of current. Okay, so this is the symbol of the PN junction diode. Okay, this has two terminals, terminal 1 and terminal 2. Okay, then what are the different mode of operations this PN junction diode. Okay, I have a device, I have a PN junction diode. How to connect this PN junction diode in a circuit? Okay, if I connect in a one bias, how it works? If I connect in another bias, how it works? Actually, what are the different types of bias? Okay, there are three types of biases majorly. One is zero bias, second one is forward bias, third one is reverse bias. Okay, zero bias in the sense we are not applying any external voltage to the this device is nothing but PN junction. Like that means without giving any external energy, the diffusion takes place and PN junction forms. Okay, that is zero bias. That means there won't we are not applying any external voltage. That means this image represents the zero bias of the PN junction. Okay, then what are other biases? Okay, one is forward bias, another one is reverse bias and forward bias. Then we are going to learn about what is forward bias and what is reverse bias and what is the use of forward bias and what is the use of reverse bias and what are the characteristics of forward bias and reverse bias. See, forward bias in the sense we are going to apply the positive terminal to the P side, that means anode, and negative terminal to the N side. Negative terminal means negative terminal of battery. Let us see that means. This is the positive terminal. We are going to connect with positive, and this is the negative, and P side will be connected to the positive and N side will be connected to the negative. If we connect like this P side will be connected to the positive of the battery and N side is connected to the negative of the battery, then we will call it as a forward bias of the PN junction. When we connect like this, what happened? That we will see now. You can see here, when we connect like this, P type is connected to the positive and N type is connected to the negative of the battery. We all know that same charges will be repelled. That means here this positive charge push the holes from the P side to N side, and the depletion and this negative charge push the electrons from the N side to P side. N side to P side. Then as much as we are pushing, what happened? Because of this external energy, once we got the threshold voltage, then these charge carriers can able to break the depletion region and current flow takes place. Current flow takes place. That means in a forward bias, because of the same charges we are applying, that means positive terminal connected to the P side and negative terminal connected to the N side, the charge carriers are pushing towards the junction. Then what happened? The region of the depletion region will be decreases, or sometime after some time it may be disappear because of high flow of the current. Okay, that means we in forward bias, what happened? The depletion region will be decrease because of that P type is connected to the positive and N type is connected to the negative. All the electrons are pushing towards the P side and all the holes are pushing from towards the N side. So that, okay, the depletion region becomes narrow in forward bias and the flow of current in the range of milliamperes. Flow of current in the range of milliamperes. And as much as we are increasing the voltage, what happened and how the current will be increased, that we will see at the end while explaining about the IV characteristics of the PN junction diode. Then let us go for the reverse bias. So reverse bias in the sense, simply we are going to connect the positive terminal to the N side and negative terminal to the P side. reverse. Positive terminal to the N side and negative terminal to the P side. That means electrons which are there in the N side will be attracted towards the positive terminal, and the holes which are there in the P side will be attracted towards the negative terminal. That means we are pulling back the charge carriers from the junction. In the forward bias, what we are doing, we are pushing the charge carriers towards the junction, and we are making them or triggering them to cross the barrier and to leads the flow of current in the PN junction diode. But whereas in the reverse bias, what we are doing, instead of pushing the charge carriers, we are just pulling back the charge carriers. When we are pulling back the charge carriers, what happen? This whatever the electrons that will be attracted towards the positive terminal, and whatever the holes are here that will be attracted towards the negative terminal, then the width of the depletion region will be increases. The width of depletion region is increases. As much as the width of the depletion region increases, the flow of current decreases in the material, and it will be act like a perfect switch. Even though if you increase the reverse bias voltage, what will happen, that we will see in this. So it is very clear. In the forward bias means positive terminal connected to the P side and negative terminal connected to the N side, whereas reverse bias means positive terminal connected to the N side and negative terminal connected to the P side of the material. In the forward bias, very most important thing is the depletion region will become narrow and the flow of current increases. It is in the range of milliamperes. Whereas in the reverse bias, depletion region will be increases as much as more because of the pulling the electrons and holes from the battery, and because of the wide range of depletion region, it will be act like a switch. Even if you increase the little bit more reverse bias voltage, we will get a small amount of leakage current. That leakage current in the sense reverse bias current. This reverse bias current is because of the minority charge carriers. Minority charge carriers. Minority charge carriers means we know that in the N side some holes are there, in the P side some electrons are there. It doesn't mean that P side means it is a completely holes or N side means completely electrons. They are just majority charge carriers. So that hence there are still some minority charge carriers are existed. If we apply little bit more and reverse bias voltage, then this voltage is enough to pull the electrons which are there in the P side towards the across the barrier towards the positive terminal, and this junction also pulls the electrons from the N side to the P side across the barrier whatever they are present in the N side. So minority charge here holes are there and here electrons are there. These minority electrons are attracted towards the positive terminal, and this minority holes are attracted towards the negative terminal. Hence we will get some flow of current. That flow of current is known as reverse bias current or leakage current. Now even though if you increase little bit more and more negative voltage, what happened in the reverse bias? At the same time, if I increase more and more positive bias voltage, the forward bias voltage, what will happen? That we will see in VI characteristics of PN junction diode. Okay, as I said earlier in the little back, okay, we can clearly understand that if I want to get the flow of current in PN junction, I must be able to apply the voltage which is greater than the threshold voltage. So that even though if I apply the voltage, little bit of voltage, that is not enough to mark the flow of current through the junction in forward bias. This is the forward bias and this is the reverse bias. Okay. So even though if I give little voltage, that is not sufficient to cross the barrier, so that I should give minimum amount of voltage to get the flow of current in the forward PN junction in forward bias. See, we can see clearly initially the flow of current is 0, but as much as increasing the voltage, it is slowly increasing. Then after, if I increase little bit more and more voltage, what happen? It will be saturated like this. That means, let us take one example. I have started my vehicle, that is a bicycle or something. If I have started a motorcycle, if I am moving through the metal road, or if I am moving any water logging area, then my speed is very very less, that is 0. If I enter into the metal road or single road, my speed will be increased slowly. Then if I enter into the double road, my speed will be increased much more. Then if I enter into the bypass or highway, expressway, then my speed is saturated. Whatever the maximum speed is applicable, that is possible. Similarly, here also, by giving little voltage, we can able to increase that flow of current in the junction. That means, if very much low voltage means there is no flow of current. If I give little bit more, then the flow of current takes place through the junction. If I increase a little bit more, the speed, the flow of current will be slowly, gradually increases. As much as I increasing the biasing voltage, the flow of current will be steadily increases. If I increase much more, then there won't be any depletion region. It will be disappear, and maximum current will be passing through the PN junction diode. Okay, then current will be saturated. Similarly, we can see in the reverse bias, yes, minimum amount of leakage current is possible by giving the reverse bias voltage. We can see that there is a flow of minimum amount of biasing current, that is leakage current, is possible in reverse bias. But if I increase much more reverse bias voltage, whereas in the case of forward bias, if I increase more forward bias voltage means the current will be maximum and it will be saturated. Similarly, in the reverse bias, the flow of current in the range of microamperes, that we will call it as a leakage current. Then as much as I increasing the reverse bias voltage, I can able to see that at a particular voltage, a sudden drop of the sudden increase in the reverse bias current also. That region is, that voltage is known as breakdown voltage. Breakdown voltage. Okay, that means there is a possibility of break down the diode and a reverse bias, even if we apply a heavy reverse bias voltage. That voltage is known as reverse breakdown voltage. That means the current will be suddenly increases from 2 to 3 or 10 microamperes to 100 microamperes. But what is the difference between PN junction and GNR? We will see in the next class. In that, the whatever the breakdown, it is not controlled in the PN junction, but whereas in the GNR diode, we can able to control this breakdown also. That we will explain in the GNR diode class. Okay. Now it is very clear that in a forward bias, the flow of current will be slowly increases and it will be saturated. In the reverse bias, the flow of current is in the order of microamperes and very low. But even in the reverse bias also, if we increase much more reverse bias voltage, then there is a sudden increase in the flow of current will be takes place, but it is in the order of microamperes only, that is 100 microamperes or some other. Okay, so that voltage is known as reverse breakdown voltage. Then let us go for the applications of the semiconductors. Okay, semiconductor diode. This semiconductor diode widely we are going to use in photodiodes. Photodiode, or else we can also simply use that another word, optoelectronic devices. Optoelectronic devices means the devices which converts the optical energy into the electrical energy, or electrical energy into the optical energy. Okay, all these type of devices, the major instrument or major device is PN junction diode. Okay, photodiode in the sense of pin diode or avalanche photodiode, pin diode, avalanche photodiode, solar cells. These are the different photo detectors, okay, which converts the optical energy into the electrical energy, or electrical energy into the optical energy. Similarly, we can also use this PN junction diode in forward bias to get the laser beam in semiconductor laser or to get the LED, light emitting diode. So different PN junction diodes are reason for different colors of LEDs. Okay, by varying the different materials in the PN junction, P type and N type material, we can vary the different colors of LED. Okay, so PN junction diode will be used in LEDs in forward bias, in a lasers also in forward bias, in the PN junction used in reverse bias for pin diode and avalanche photodiode, where we can convert the optical energy into the electrical energy. And another one is another application is we will use this PN junction diodes as a rectifiers. Okay, we all know the importance of rectifiers, which converts the analog signals into the DC current, analog signal to DC current. Okay, AC current to DC current. This is very essential for many householding applications. All this will be happen with the help of semiconductor diode or PN junction diode. Okay, so with this I am concluding this. Okay, this PN junction diode, what is PN junction diode and how the PN junction forms, what is the depletion region, in forward bias how the depletion region decreases, in reverse bias how the depletion region increases, in forward bias what is the flow, how the flow of current increases and it will be saturated, in the reverse bias how the breakdown will be happens, and what are the applications of semiconductor diode, that is PN junction diode, have been clearly understood in this class, I think. Okay, these are the various references pages which I have followed to adapt to. I have taken the different images from different web pages. Thank you, Ananda.